again, everyone. Okay, so skill 2. Now we've graphed it. So what about evaluating and solving? Evaluating means that you are finding a value given a certain restriction, given a certain parameter. So that's what we're going to take a look at. Yes, these notes are super, super quick. Yeah, you're welcome. They're actually really, really important though. So if you have questions, make sure that you're always writing down questions, maybe on the side of your note guide, or you have a little notepad for specific questions that you want to make sure get answered by me, by your classmates, by your accountability groups when we get into those this week, okay? I'm writing myself a note right now as we speak so I don't forget something. So I highly recommend finding a method that works for you. Okay, so it says using the equation above, in case you were wondering, colors. I love colors. Okay, that is this guy right here. Okay, that is the equation. Now I know it looks funky. It's not one line, Miss Patterson. It doesn't have to be. Okay, what matters is that it is f of x equals, it has an equal sign, and it defines the equation. It's saying that 2x plus 1 when x is less than 1, and so forth. So here we go. If we know that it's f of x, this bad boy, and I'm asking you to identify f of 4, ladies and gentlemen, the first thing you need to do is check the domain restrictions. I'm going to say it again. It's important. You should write it down. You need to check the domain restrictions. Okay, what that means is, if I can erase those, I'm going to look at the first one. X less than 1. Is 4 less than 1? And we're going to say no. So this one is not the piece that corresponds to f of 4. Okay, the second, is 4 greater than or equal to 1, but less than 4? Well, no, 4 is 4. That doesn't count. Is 4 greater than or equal to 4? And we say yes. So what that means is we would then take this x value and substitute it into the piece that it corresponds to. Well, there isn't any input area. There isn't an x for us to substitute in 4. So that means f of 4 when x is 4 corresponds to 1.5. When x is 4, y is 1.5. Okay, I'm going to say that again just to get comfortable to the terminology, the vocabulary. When x is 4, y is 1.5. Okay, so looking at the second example, if x is -5, what is y? Because remember, f of x is the same as y. It just means function of x. What is my output when my input is x? Now you guys are in higher level math, right? We're in big kid math. And we've got fancy notation. So it's really important that we get comfortable with that. So f of x, function of x. Okay, so is -5 less than 1? Heck yeah, so we're done. It's nice when we find it the first time around, right? So 2x plus 1, which means f of -5, we're going to take -5 as our input. We're going to put it or substitute it in for x, and we're going to use our order of operations. First comes multiplication, so -10. Oh my gosh, thank you, cloud update. I don't know if you guys can see that pop up. Plus 1. So f of -5 is going to be equal to a -9. What that means is when x is -5, y is -9. You can always go to your graph and check. So if I would go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, it would be down here somewhere, which looks like it would absolutely correspond. Okay, so if you do have a visual, it's nice to be able to check your math at that point. And last but certainly not least, yeah, this doesn't look the same. Read the directions. Yep. Find x. What are we looking for? X. If you said x, you are correct. When f of x is equal to -5. So we have 3 pieces. We're going to test this, find our solution 3 different times. Okay, this means when y is equal to -5. What you're going to do is you're going to take -5, and you're going to set it equal to the first piece of our piecewise function. You're going to take negative 5 and you're going to set it equal to the second piece of our piecewise function. You're going to take negative 5 and set it equal to the third piece of our piecewise function. And one by one, you're going to solve for x. Okay, so going back to the first one, I'm going to subtract 1. So I get 2x is equal to negative 6 divided by 3x is equal to negative 3. Okay, so step 1, set every piece of this equation equal to the given y value. Step 2, solve for x. Step 3, go back to the given equation and see if that x value exists within the restricted domain. If you need to pause the video or rewind it to hear those 3 again, please do. Okay, so we're on step 3. Is this x value in the restricted domain? Is negative 3 less than 1? Yes, yes it is. So that's one of our corresponding x values when y is negative 5. But you have to test them all. Okay, so here we go. I'm going to subtract 7 halves. So that means that we have negative 10 halves minus 7 halves for those that need to see it, equal to negative 1/2 x. I just got common denominators with the 5. So we have negative 17 halves is equal to negative 1/2 x. We could divide by a negative 1/2 or just multiply by the reciprocal, which is definitely the easiest way to go in my personal opinion. Okay, so x is 17. Is that in this restriction? No. So that is not a solution. Okay, we have to test them all. I can't stress that enough. If you're a forgetful human, write that down. You have to test all the pieces. Maybe you put in a little smiley face. Okay, so then is negative 5 equal to 1/2? No, it is not. So let's go back to our graph and see. Y is negative 5. 1, 2, 3, 4. We're right here. Does that make sense that it would only intersect the first function, which was our yellow function? Yes, it absolutely does. So our only answer is x is equal to negative 3. Now, if you had multiple answers, okay, so join me in my green little thought bubble, you could just write x is equal to negative 3, 5, whatever the answers were. You wouldn't need any fancy notation for that. Okay, great. Nice job, guys. That was skill 2.